Hi, everyone. Welcome to this live stream. It's good to have everyone with us. So we'll get going in just a second. But before that, I want to do a little administrative information sharing. So first off, please, throughout this live stream, if you have comments or questions, enter them into the chat. We will address questions at the end of this, and any of the best comments that come through, we'll also share those. So if you're feeling a bit festive, then put some funny comments in there as well. To get started, I'll give an icebreaker for everyone to practice the chat functionality. So I'd like everyone to chat in where you're joining from, and also what the weather is outside. This will be a global audience, so we might get some good, interesting weather reports. So we'll start with our two co-presenters here. David, can you share where you're connecting from and what's it like outside?
Sure, Justin. Well, I'm here just outside of Boston, and it's typical New England weather. Right now, it's gray and a little chilly. A little bit of wind coming along. We've got all the leaves down, so the trees are nice and bare, and hoping for a little bit of snow, maybe even get some snow before the holiday season.
Fun stuff. All right, Chris, your turn.
Welcome to everybody on the live stream. I'm based out of the UK. I'm in a town called Bedford, and it's pitch black outside. It's gone nighttime.
All right, so who knows what the weather's like. And I'm coming from sunny California, where we've actually had, in the Bay Area, where we've had some rain, surprisingly, in the last few days. So that's positive. The grass is
needing that rain.
Yeah, we need it, yeah. So again, everyone, feel free to pop into the comments where you're connecting from. And I think with that, we'll go ahead and get started. So my name is Justin. I'm in the product management group here at Cloudera, within specifically our data warehousing product area. So I work day in, day out to help create products that customers can use for their data warehousing and analytics needs, specifically as they move over to the cloud. So today we're going to talk about the future of data warehousing and data lakes, and also importantly, based on what we need to support in our business decision making, whether to keep them as separate, parallel environments, or to join them together. So I'm joined with some esteemed colleagues here to help explore this topic. So supporting the data warehouse side of things, we have David Dickman. He's a director of product management here, specializing in our SQL tooling and visualizations, but also our data warehousing platform in both public and private cloud. That's a long sentence there. David, I'll let you share what that actually means in terms of your day-to-day activities.
Sure. So where I'm helping folks these days is we want to be able to make data easy to access and easy to share. And that's all about things like using Hue for SQL editing. So I'm responsible for managing our Hue portion of the portfolio, but also in making visualizations easy to get at and share. And that's where we're using Cloudera data visualization. It's a new component that we've released in the last year or so. That was from our acquisition of Arcadia Data. And some of you folks may even remember me from a past life where I was supporting information architecture and modeling solutions for Sybase and SAP. So happy to be here.
All right, great, thanks. And supporting the data lake side of things, we have Dr. Chris Royals. He's a field CTO for EMEA with Cloudera. So Chris, your turn to give us a day in the life of summary.
Yeah, sure, thanks. I've been spending a lot of time recently with customers, talking at roundtables, really helping share and collaborate on trends in the industry. I tend to have a sort of 3 to 5 year horizon in some of the work I'm doing, looking at some of the strategy for technology. I kind of look for long-lived projects, accessibility, for example, certifications in terms of security, especially in the EMEA region, encompassing areas such as the EU, and really understanding what our customers need and working with them on their strategy. Areas such as the right skills at the right time in the right place and applying that to your organization. Those are the things that take most of my time on an average day.
All right, great. That's a busy day, it seems like. So let's get to it. All right, first, let's first explore a little bit how folks are using data warehouses and data lakes today. So David, we'll start with you. Why? I'll put a theoretical question out there. Why should I continue to invest in data warehousing today? It's been around for decades, pretty mature, well understood space. So why is it still relevant today?
Well, Justin, when you think about data warehouses, I like to think about why are we using them and what's the right fit for purpose. I'm a big fan of this notion of fit for purpose. So data warehouses traditionally have been where we've focused on getting that highest degree of precision, curating the data carefully, making those aggregations so that we can get at the answers to the questions we need to ask with the highest degree of precision, of trustworthiness, of reliability. And to do that, we've invested in ways to make sure that we count everything, count it only once, and don't leave anything out, because we're dealing with questions like, am I paying the right amount of tax to the government? Am I complying to regulations accurately and correctly? And more to the point, am I measuring my business and keeping score correctly so that I'm making the right decisions based on how we have performed? So with that said, the reason why we want to continue to look at data warehousing is we still have a lot of these burning business questions that need to be answered in a very careful way to make sure we get those answers accurately and correctly. Do we have our inventory right? Do we have our financials right? Do we have our health statistics right? Do we have these things right in a very precise way? And we can't be wishy-washy about those answers.
All right. Wow, sounds good. Seems like there is still a place for these. But at the same time, it seems like there's some business questions that the data warehouse cannot answer, at least not without significant delay or without incorporating all the information found within the data that might exist at your disposal. And ultimately, that's what led to the rise of data lakes and big data solutions going on 10 or 15 years ago. So, Chris, can you share with us like what in your experience has led to the continued investment in data lake solutions on the other side?
Well, if I think in terms of data warehouse and where we're helping organizations that may have a data warehouse and are thinking about using different technologies, data lakes tend to come into play because they need to scale out. They're beyond a few hundred terabytes. They're now into petabytes of data that they need to bring under management. And a data lake is a really cost-effective way of doing that. The other thing with data lakes is they're able to handle a much broader range of data types. I remember a piece of work I was doing with one customer, and they had a lot of textual analytics, a lot of text as, if you like, fields in the database, but they'd all been trimmed. And so we'd lost a lot of insight in those kind of relational database because of that data being trimmed in order to fit into a particular shape in the data warehouse. In the data lake, you can go back, if you like, to the raw data if you wanted to interrogate that. So it enables you to interact with that data in its raw form, as it was originally presented, but also interact with that data in let's say, a fresher way as it's landing. If you need to, if your use case requires it, you can be interrogating it live. And the other thing that I find with data lakes is, to your point, Justin, you don't need to make that initial investment on what data is important and why you might need to move it into a data warehouse for more accurate reporting. You can take that data and start to work with it against use cases without really understanding its value up front and without spending money on curating that data. And so that it's really about when in the process you start to derive value from the data. And the thing with the data lake is it gives you flexibility in when you start to derive the value from that data. You could just leave it there doing nothing for a while if you needed to. If you need value from it, go ahead and get value from it when you choose to do so.
So now, Chris, from what I'm hearing, though, some of the use cases you're talking about aren't purely data lake use cases, are they? Aren't some of those use cases requiring combining some of that raw data with really well-curated, precise data that would be found in a data warehouse?
Yes. I'll give you some good examples. We work with financial institutions, say a bank, and they'll be looking at very accurate transactions that are, to your point, very critical in terms of when they occur and that they're counted correctly. We all want to be paid the right amount of money, let's say. So these things have to be correct. But alongside that, there's also a lot of information that's attached to that. You could treat it as kind of like a metadata. Think of it as a separate set of information. And in financial services, we're seeing, let's say, offloads from what you might consider a mainframe to that data lake pattern in order to be able to gain access to larger volumes of information. The reason for that, if I think in terms of one of our customers, they wanted to present into the palm of your hand every financial transaction you've ever made. They couldn't do that off their traditional mainframes, but they could do that off their data lake. What's also interesting is they're able to apply multiple use cases to that. So not only are they presenting to every customer every transaction in history in the palm of their hand, what they're also able to do is fraud analytics across those transactions as well, over a much wider period of time. So they bring seasonality into play. They can look at how seasons affect certain trends in how these transactions occur. So they brought the customer in the loop. The customer's part of that fraud validation piece, and they're also able to do their back-end analysis of the data as well. Think of it as a multi-use case kind of problem that they're applying there. And that's what the data lake really helps them achieve. They're able to manage that at great volume. We are talking multi-petabytes here. And when you think of multi-petabytes of data in a data warehouse context, that can be a little challenging. So that's an area to sort of explore. There's another use case as well, which we come across quite often in manufacturing. And what we find in manufacturing is there's kind of two types of data. And manufacturers are trying to do two things. They're trying to drive their production processes more efficiently. So if you're making steel, how do you make more of it? How do you get more of it through your system? But as you drive more through, you get a higher rate of failure, and you have tolerance to failure. So the quality of the product might decline. So what's the tolerance of quality on the product? And so in order to drive both of these types of use case, some of these use cases can be tens of millions of pounds of new revenue in terms of the amount of products being generated. In order to drive those use cases, we need to be taking telemetry. And the telemetry sort of falls into two categories. You got the data from the sensors, which can be in very raw and various structured form, and it's arriving very quickly in great volume, and you have to act on that very, very quickly to stay ahead of it. But then you're joining it with more structured and curated data. For example, what sensor am I talking about? What's the setting of that sensor at that point in time? And what's the correct behavior of that sensor? When did we maintain it? When did we repair it? When did we replace it? These are very curated sets of information that, to your point, would be better placed in the data warehouse as a managed curated set of information, but joined and related, if you like, to this other telemetry that's coming in that's in a far more sort of semi or unstructured form. So those are two really high-level use cases that we see very common when we need to start bringing these two concepts of the data lake and the data warehouse closer together.
Good. Yeah, those are good examples. So I like a couple of the points you made. I was jotting down notes actually. The flexibility on when to start using the data, when to tap into the data. Like that's actually a really powerful concept, because you might not know once you ETL it into a warehouse if there's something useful. You might have lost that information. That seems pretty powerful. And also the multifunction analytics, combining different types of ways to work with the data into one end-to-end use case that a data lake pattern gives you. So those were good examples, I guess, Chris, from your perspective of sort of starting from a data lake perspective and when you might want to weave in some of the data warehousing strengths, Chris. So David, I wanted to ask you from your perspective, maybe starting from the data warehousing perspective and looking at when to leverage a data lake to enrich what you're doing on the warehousing side. Do you have some other examples that you can share from what you've seen out there?
Yeah, Justin, as a matter of fact, I was listening to what Chris was saying, and one of the key elements that he's talking about, those two key elements is the speed and rate at the way certain data will land into your environment, and being able to access that quickly without taking the time to build out the full mature ETL, dev, test, deploy type model, but also the granularity. So for example, in the life sciences space, we're working with a large data life sciences aggregator, and they have these data sets that have been well curated to help us understand what's going on in the medical world, but they're being able to combine that with trial data that's landing raw in the data lake. Everything from heart rate, blood pressure, temperature, and more at full granularity, and being able to perform analytics on what's happening now in real time with trial data, with patient data, with the trends that materialize from that curated and aggregated data. They're able to dramatically cut the time it takes to execute certain trials, which deliver life-saving medicines and life-saving medical procedures into the medical world faster and ultimately saving lives. But it's this notion that we need all of this data at its high granularity combined with some of the aggregated data where those trends can materialize to be able to realize the value of this data in as close to real time as possible.
Good. Makes sense. So I guess it sounds like we're coming to a consensus that we do really do need a platform that's not just a warehouse, not just a lake, but something that's got the best of both worlds together. And We've seen the industry start talking a lot about lake houses. That's a term and a category that's been floating around for a few years now. And honestly, like, customers have been doing that pattern on Cloudera for much of the last decade, initially primarily in the on-premise world, and now more and more so out in the public cloud. So I guess, do you guys see the future of analytics really as being something like a single platform, a lakehouse, if you want to call it that, instead of separate investments into these different types of platforms? And if so, what are maybe some of the key characteristics that is needed by a platform that can enable a lakehouse style deployment pattern? So I'll start with David on this one.
Sure. Well, I know one of the big things that we see our customers looking for, first and foremost, is where is the data going to be, and how much of that data do we need to copy and move? We really want to get to a no data copying environment where wherever the data is, we separate compute and storage. We bring the compute to where the storage needs to be so we can get faster performance. We can reduce costs. And especially as we go from fixed on-premises purchasing to consumption in the cloud, being able to have the right compute work in the right cloud, whichever cloud it may be, public cloud, private cloud, as well as combine that with data that is born in the on-premises world and may remain in on-premises for some time. Being able to bring all of that together in a cohesive way without copying and moving the data all over the place, dealing with those data egress costs and dealing with additional compute costs that are unnecessary when the data is not where the compute is being run.
Okay. Chris, your perspectives on that?
I think that's a really interesting example of where a data lake and a data warehouse kind of come together, in that you should be able to do that curated data warehouse-like experience when you can run very high-performance SQL analytics across data sets that are curated. But that data and the journey it's gone through, that no-copy element, all resides on the data lake. And to your point, Justin, we've been doing this for a number of years. The Cloudera Data Warehouse can sit on top of the Cloudera Data Lake and present in many different ways. One of the things I think that is really fundamental with that, though, is making sure that we are reflecting here that this is an enterprise-grade platform. You have to have that central governance. One of the things I explain to my customers quite often is how we do the security and governance. And if you just build that up, if somebody in Tableau can access the Cloudera Data Warehouse, they're hitting an endpoint, say on the cloud or in their data center, what then happens from that endpoint is it goes through the query planner, it goes through the SQL engine itself, and that goes down onto the storage tier in the data lake. So why are we using the data lake? We're using the data lake for economy. We're using a cheaper type of storage that's very, very robust to enable us to store and manage vast amounts of data at a very, very low cost. So that query planner and that SQL engine then can read that data, maybe even has to decrypt that data if it's encrypted, and then pass it back up the stack. So it goes back up through the SQL engine, back up through the query planner, back up to the endpoint, back out to the client. We've got to turn that query around in less than a second, some cases fractions of a second. But at every level, we're authorizing and authenticating that query is valid. We're applying policies to say, do we need to redact any of these columns? We're applying security to say, can this service, this query engine, query this area of the file system on the data lake? And can it load these blocks from the data lake and decrypt them? All of this happens in that fraction of a second. And just building that up and understanding that the central governance enables that. It enables it not just across multiple instances of your data warehouse and data lake. It also happens in depth as you go through the tiers in the platform. But the timeframes involved are effectively, to the end user, real time. They're getting the answers when they need them, redacted and managed in the way required by governance and policy, typically centrally managed. So what it does is it brings that easy use. You use the tools you're familiar with every day, and integrating the way you need to do it with all that security and governance built in. And I think that becomes really important when you start thinking in terms of combining data lakes with data warehouses.
Well, and Chris, what's interesting about what you just said there is when you have that kind of central security and governance, or one definition of security and governance across everywhere where the data may be, it gives us a lot more freedom to use and leverage that data in a lot more use cases. And as a result of that, we also see that there's a high demand to do more than just one thing with our data across the life cycle. And that in order to be able to really take advantage of a data warehouse, data lake combination, a lake house, is we need to be able to integrate functions like data engineering. We need to be able to integrate data flow and streaming so we can capture those new data sources that are coming from the edge. We need to be able to integrate machine learning and AI tools so we can perform those more advanced predictive, statistically motivated predictive analytics that are really well suited to data that may be in a more raw form, when we need more or less trends versus exact precision combined with exact precision. And by being able to have an environment where we look at the data separate from the way that we use the data, and we can bring different user experiences to that data, to the same data that every other experience is working with. We're doing AI in our data warehouse, in our data lake, with data engineering, bringing all of that together, full data lifecycle for those modern use cases. This is really where we see the best advantage of a lakehouse coming to bear fruit for the enterprise.
If I just build on that, there's a good use case for when you get into machine learning. You've got two types of data to consider. You've got that structured information that might well represent, say, your customers and how they interact with your services. But in many cases, we're seeing this in industrial engineering, for example, that quality use case I used earlier, a lot of image and video material. So that image and video material is well placed on the data lake, on the file system of the data lake. Whereas the data warehouse is presenting the more structured information, the metadata that goes with that information in terms of the temperature profile or the features that are actually in that image that may have been pre-scored. And so when you then bring machine learning to play, you'll be interacting with structured features in the data warehouse and maintaining those and saving and persisting those so you don't have to continue to run your data engineering pipeline, so feature stores in the warehouse, whilst integrating with video and image content that sits on the data lake. And this is a very traditional kind of use case we're seeing now in both automotive and industrial engineering. It's a really good example.
So I have a question, I guess. So there's a lot of really powerful concepts that you guys have shared, but let's not forget about the end users who actually have to benefit from the data. So David, your world focuses largely around end user tools, whether it's SQL developers or dashboarding and visualizations. Can you talk a little bit about the end user ease of use aspect, and then what sort of either requirements or perspectives we need to keep in mind for those types of users when we look at this lakehouse type of pattern?
Well, absolutely. And there is a lot of inherent complexity that is underlying these environments, yet from the end user perspective, from the line of business analysts, the data analysts, and the folks that need to use the results of these analytics for their day-to-day decisions, we need to provide the right level of ease of use, everything from the admin side to auto provisioning of the right experience, auto scaling to make sure it's cost effective, but also easy to query and have query tools that allow folks to collaborate together and build what I like to call those beautiful SQL statements for those advanced users who are able to slice and dice through schema and data, but also create visualizations quick and easy right off of the platform with things like Cloudera data visualization or any of your favorite BI tools plugging into the interfaces that give you access to this data, and be able to create those charts and graphs and things that give instant visual recognition to the answer to the question you're asking. If the pie chart showing something that's positive to continue to reinforce a business decision, or negative to indicate that we need to make a change. And all of this has to happen with very little, if no, interaction with IT to get from data discovery to data use.
So if I could maybe net that out, more self-service and ease of use for those who actually need the data, with IT and ultimately with the infrastructure just getting out of the way. Like let's not worry too much about that, whether it's via intelligence at the infrastructure level, so it can size correctly and things like that. But that also brings me to the other thing which we should not forget in all this, which is price, especially in the public cloud context. The faster you can run something, the faster you can release the resources, and you're not paying for it anymore. So it's no longer just performance or price. It's really the price-performance ratio that matters. So Chris, I mean, what are you seeing with customers that have adopted this pattern? How are they thinking about and reasoning about and maybe even budgeting for these types of capabilities, looking at this price-performance ratio?
Great question. My default response to that is always be data-driven. So we're looking to work with organizations to sweat existing assets. So if they have servers and clusters in their data center, we'd want to upgrade those to a private cloud form factor. And that private cloud form factor bringing in elasticity, bringing in separation of storage and compute. And what I mean by that is the data lake provides the storage and centralized governance, and then the compute becomes something, to David's point, that can be self-served by the lines of business rather than by IT. And then when you go to the public cloud, it's about making sure we optimize the platform for the right form factor. So if we're on Amazon, we'll be using Amazon's data lake to drive lower cost, and we'll be using the managed Kubernetes service, for example, to drive elasticity. Likewise on Azure. And so the platform is designed and configured and built to optimize for each of the form factors we deploy to. So that provides a very cost-effective way to deliver multi-cloud, deploy on more than one cloud, private cloud, sweat your existing infrastructure assets if you choose to, and then integrate the two. So our shared control plane provides governance. What's interesting with that shared control plane is when we talk about centralized governance, we talk about it between public, multi-cloud, and private form factors. And we're integrating all of our governance across those different form factors. And so when we think in terms of data lakes and data warehouses, you're able to provision those data lakes wherever you need to, wherever your data is, and wherever the assets are that you want to continue to utilize as part of your infrastructure. So that's where we're thinking in terms of the cost, the return, the total cost of ownership, and how we minimize that cost and optimize it for you in terms of the customer.
All right, good stuff. So let's maybe switch over to Q&A. I'll get it started. So thanks to those who have entered in questions already. Please continue to do so in the comments for whatever platform you're on. Well, I'll start it with one, and actually I'll hand this one initially back to you, Chris. So I feel like we've made the case for a lakehouse style of architecture. Can you share some examples of very recent innovations that Cloudera has put out to be able to satisfy this lakehouse pattern? Again, factoring in the price, the usability, and all the stuff we've talked about.
I think there's a few areas we've made innovations, probably three topics worth talking about. One is in the data warehousing domain. So singular data warehouse, singular SQL service now. And we've added in capabilities or brought in under support a number of features. And in summary, data sketches enable very fast querying of vast amounts of data, stored procedures. That enables the migration of traditional relational databases into the data warehouse and into the data lake, and the ability to federate as well. So our data warehouse can now, singular query interface, federate out to external sources. So it's worth exploring some of the innovations we've added in there. The second one is Unicorn. That sits within some of our runtime technologies now, such as our data engineering services, and thinking around that being optimized for running Spark in containers. And it can deliver up to 2 to 4 times the throughput in terms of performance of that container scheduling. So we utilize that on public cloud, and we utilize that on private cloud to drive greater efficiency in terms of how those data engineering pipelines execute and run. And then the final one probably is ready flows. That's part of our data flow portfolio. Ready flows sit within the shared control plane, so they can be applied sort of centrally, but they can be deployed into each instance. So I can establish event-driven processing to move data from one element or area of my data lake to another. We are creating a copy in that case, but it's based on a flow. And so we can configure that flow and automate the task. So that's really good if you want to take raw data and maybe curate it into something that's optimized for analytics. That step you might take within the data lake to optimize that data. It's also really good when you want to do cross-cloud sort of movement of data. So you can take a flow, take some data landing in Amazon, and maybe take it across to Azure based on a set of policies. You know, what data do I want to move at a point in time for a particular reason? And so that multi-cloud aspect comes into play as well. So take a look at data flow, and an aspect of that being the ready flows, which are single-click provisioned flow for moving data around through the platforms and through the instances.
And there's one other innovation I'd like to add to that, Chris. Those are excellent examples. But one other thing that we've been doing in the data, and actually across the whole platform, is we're incorporating a technology known as Iceberg. What this gives us is a new storage format that allows us to dramatically reduce the latency associated with managing metadata, giving us greater performance in getting our data results back, but also gives us the power of time travel. And this works across the whole platform in machine learning, in data engineering, data warehousing, operational database, everywhere where will be managing data that is stored, you can take advantage of these new capabilities.
All right, so before the next question, I'll do a readout on some of the chats we got from where people are coming from. We truly are following the sun here. We have Turkey, London, Dubai, Argentina, Senegal, Costa Rica, Toronto, Washington, D.C. Pretty good coverage. Thanks for those that stayed up late for this, I guess, for those in Europe and Africa. Okay, next question. This is coming from a viewer on YouTube. Why doesn't Cloudera integrate new components into public cloud, which can run accelerated queries instead of just relying on Hue? Maybe I'll repeat that. I'll hand that to you, David. Why isn't Cloudera integrating new components into public cloud to run accelerated queries instead of just Hue? Do you have any thoughts on that?
Sure. Well, if I understand the way the reasoning for this question is, we're looking at different types of use cases. Hue is designed to help an SQL developer develop what I like to affectionately call the beautiful SQL query. And as a result, we have the ability to retrieve data sets from the database, but Hue is not designed to be a robust BI environment to provide true performant dashboards and reporting to the end users. For that, we incorporate both your choice of BI tool to work directly against the Cloudera data warehouse running in public cloud. So you can bring your own Click and Tableau and whatever it is that you want to bring, Power BI. But we also have our own Cloudera data visualization, which was a technology we acquired from Arcadia Data. And they specialize in exactly that kind of thing. How can I provide large numbers of users access to large amounts of data stored in an environment like the Cloudera data warehouse and the Cloudera data platform, and provide meaningful visuals back? So you get that accelerated query and that query performance, and you also get the visualization, because that's its fit for purpose. So Hue's around helping accelerate development of queries that we can use in visualization, and Cloudera data visualization is about delivering that data set to the point of decision and get it there in the most efficient and most visual way possible.
Okay, Chris, anything you want to add to that?
I just expand, actually. It's a very open question, so it's difficult to understand maybe what we're talking about in terms of accelerated queries. But if I give it a shot as well, one of the other things we've brought into the data warehouse is the ability to materialize views. So they're logical representations, but we can materialize them. The reason this becomes really important is if you're thinking in terms of business analytics and you want to do roll-ups and you want to do complex analytics, materialized views might solve that. That is now part of our platform and is available on public cloud today.
Right, and we just had another one, interesting one come in here that I'll read out. So let's see, what do you think about new tools allowing data as a service, such as Dremio? So tools allowing data as a service sorts of architectures. Dremio is an example, and there's others. So this is a question from LinkedIn. I'll just put that one out to either one of you. You want to chime in?
Chris? Yeah, go ahead, Chris. I'll give you first response on this one.
I think the thing to consider is the data warehouse, I mentioned it earlier, can be used as a federation service as well. So treat it as a singular SQL interface that then federates out to not just the underlying data lake. So that can be one source, but also other sources. And there's a range of external sources that we support. So if you're thinking in terms of it being a service, that might be an approach. Another thing to look into is our SQL Stream Builder is part of our analytics service. As you define in SQL Stream Builder, effectively SQL tables using DDL. So I want a table, I want it to be a source, I want another table to be a sink, and now I'm going to craft some SQL, create table or insert into from source. I can start to create flows entirely using SQL, and those flows can incorporate change data capture. And so what we're finding is that enables a really nice way of ingesting new data and moving data between services, but it also presents dynamically a RESTful API for those services. So you can come in and query via REST from an application against those data services, source sync, full change data capture, against Cloudera's data lake and services and data warehouse, and external third-party data stores as well. So that's our approach. That is, again, available today and fully GA. So that's an area to explore, and we'd be open to lots of feedback on that.
Well, and that is also, if we look at what we think about as data as a service, we're also talking about the notion of the serverless environment. And Chris, I believe what you've just described is a kind of serverless environment for exactly that.
Absolutely. So some of the core infrastructure behind that, and where we're going with subjects like data flow, we are looking at serverless, and we actually have a community edition. We'll be able to take elements of that community edition and deploy that into public cloud serverless managed services. So this is certainly a space to watch. We've got that in tech preview at the moment, and that'll be coming GA shortly.
Okay, good. Yeah, thanks for that. So we're a little bit over time now, but I think this was a useful conversation. I think we'll go ahead and wrap up. Appreciate everyone for joining, and especially, again, those coming from further east of the US where you stayed late at work or at home to do this. So appreciate it. Thanks for all the questions, and keep an eye out for the recording that you can share out with all of your best friends so they can view this asynchronously. So thanks, everyone. Happy holidays. Have a good rest of the day.